Well, hello, fifth grade. How are you doing? L84. Estimating the first digit of a quotient. This lesson is going to feel like we just did this. Yeah, we did. You know, Saxon gets pretty interested in this last trimester of you getting the division algorithm down. There are things that can get in our way, basic facts, and we always need those. So what I want to start, obviously, we have a dividend of 595. We have a divisor of 19. Our divisor always goes outside the house. I want to write into our notes. I know you did it not too long ago. I want to write into our notes the little kind of chart that helps us with the algorithm, where we ask ourselves a division question. That's the one that sounds like how many times does. Then we do a multiplication problem. Then we do subtraction. Then we do the arrow going down. That's the bring down. And then we repeat the process until we're done, right? So couple things we talked about before, once these numbers get a little unfamiliar, how can we navigate them? Because, we weren't taught our 19, so I can't immediately tell you this. However, remember, the important thing is that we don't think about what is 595 divided by 19. We go bit by bit by asking ourselves little questions. First, focusing on this digit of the 5 and just simply asking ourselves, 19 goes into 5 how many times? And we know that it doesn't, and this is where we're generally taught to put a little X as a kind of a marker there. Then we continue to widen out that thing, right? So we first focused on the 5 and we asked ourselves that question. Now we're going to widen it out to include the 9. Now, before we do that, or as we're doing that that 19's a little unfamiliar. We talked about how we can round it, right? We're going to round it to make it nice and comfortable. So when I ask myself, how many times does 20 go into 59? I can go with some basic facts I have. I know that 20 times 3 is 60. Now, remember what we saw last time. That might make me think, then that's going to be too much. Yeah, but we're not talking about 20. We're actually talking about 19. So 19 times 3 might still fit. And then I don't want to jump to the conclusion, well, it must be 2 then, because 20 times 3 is too much. And it's probably worth my try, because those are pretty close, to try out that 19 times 3 and see what I get. And again, I'm not going to erase any of this stuff. It's all good information. Clearly write it out. 9 times 3 is 27. I carry the 2. 1 times 3 is 3. Plus the 2 is 57. And voila, it fits. So at that point, this is where we place the 3. Remember, we place it directly above that 59, the 9 of the 59. That spacing is very important. And then we move on to our second bubble, where we're going to be multiplying. And we multiply our 3 times 19. Well, we actually already did that. Look to the left. We know that product is 57. That then moves us on to the next bubble, which is the subtraction bubble. And we're going to find the difference of 59 and 57, which is clearly 2. Once we're done with the subtraction bubble, we move down to our bring down bubble. Might draw the arrow, bring down that 5. And again, this isn't something I really have to estimate at all, because I ask myself, well, how many times does 19 go into 25? The real question is actually, what's 25 divided by 19? Because we're on that first bubble, and I would clearly conclude, well, 1. Then the multiplication bubble, 1 times 19 is clearly 19. Then the subtraction bubble, 25 minus 19, that's a basic fact, is 6. And then at this point, I know I have to move into mixed number form. Remember, our remainder, that R6, baby bed, right? Gone for a long time in our life. So that 6 is becoming the numerator of the fraction of the mixed number. How do I get my denominator? Well, remember, as we just talked about, it comes from our divisor. And we wrote notes about that last time, so I don't think we have to write notes. Now, before I box this up, I do want to consider whether that 6 19ths can be reduced. And I think about 6, I think about the factors, 1 and 6 and 2 and 3, and I think about 19, and well, 19's a prime, so its only factors are 1 and 19. So they don't have a common factor other than 1, so I can box that baby up. Let's try another. Here is the problem, 782 divided by 18. So again, I'm not going to rewrite the little kind of chart. You have it right there. You're looking at it. And again, I want to first always think about that first digit and say, well, how many times does 18 go into 7? Clearly, it doesn't. So the little x helps me with my spacing. Spacing's so important. Then, as we talked about, I can take that 18 and I'm going to round it a little bit. I'm going to call it, just like before, 20. Now, not only can I just round the 18, if you think about it, when I consider the 78, I can almost round that too and go, well, instead of 78, why don't I think about 80? So we're allowed to kind of think, and again, we're not actually changing these numbers. We're just kind of thinking about, instead of 18, I'll think about 20. Instead of 78, I'll think about 80. And then, because when I do that, I go, well, how many times does 20 go into 80? And I go, well, that's clearly 4 times. 20 times 4 is 80. So let's check out 4, and I'll test it out. 18 times 4 is, 8 times 4 is 32. Put the 2, carry the 3. 1 times 4 is 72. And clearly, it doesn't feel like I can fit another 18 in it. Remember, we don't want to undercut this, because if after the subtraction problem, if the number is greater than the divisor or equal to the divisor, I've hit a problem spot. So I should always think, well, can I fit any more 18s after the 72? Clearly I can't. So that's where I'm going to place my 4, moving on to the multiplication bubble. I already did it. And I'd say, okay, 72. Then the subtraction bubble, the difference is 6. And then I bring down the 2. And then again, well, I can do that little thing again. Well, instead of 62, why don't I think about 60? And I asked myself, well, how many times, not does 18, because who knows, how many times does 20 go into 60? Well, I know that. That's 3. So I wonder what 18 times 3 is. It will surely fit. So 18 times 3, let's check it out here. I got a 4. 8 times 3 is 24. Put the 4, carry the 2. 54. Oh, Well, the way to test it is if I subtract this, 62 and 54, those are pretty far away from each other. If I get a number equal to 18 or greater than 18, that means I didn't pull enough out. Let's check it out. 62 minus 54. Hey, that's actually supposed to be a basic fact. It's 8. So that's safe. I didn't undershoot. Remember, the 8 becomes my numerator. The 18 becomes my denominator. And then before I box this up, I should think about reducing. Well, 8 and 18, they're both even numbers. They probably have a common factor. Let's do our factor friends. So we'll set up the 8. Remember, we always start with 1. So 1 times 8 is 8. And then after 1, I should think about 2. Yeah, that's a factor. 2 times 4. And then the only thing in between 2 and 4 is 3. That's not a factor of 8. So let's move on to 18. All right, so we'll do our factor friends. We always start with 1 and 18. After 1, I should think about 2. And 2 times what is 18? 2 times 9 is 3. Oh, yeah. 3 times 6. That's in my times tables. And then I've got 4. 4 times... No. 5. Well, it can't be, right? It doesn't end in a 5 or a 0. So that's it. So what's my GCF? And I look at the list and I go, oh, 2. Therefore, as we know, what we do is we're going to divide both of these guys by 2. And then I'll represent my answer at 43 as my whole number. 8 divided by 2 is 4. 18 divided by 2 is 9. I box that baby up. And I say, that is a lot like our last lesson. Yeah, it is. There's not a lot of new to the long division algorithm. There's just kind of the need for you to become very comfortable with it. You know what we still got to get into is like, what about with decimal numbers? And that's a whole nother world. So I want you to be really good at these mixed numbers, right? Really good at mixed number quotients before we dive there. If there's any work you could be doing in regards to practicing your facts, I think you should. I hope you're well. This was, just in case you forgot, L84. The year I went to the Olympics in 84. Not me. I wasn't a participant. I was kind of young. But I saw Carl Lewis. He was a pretty amazing athlete. This is the Summer Olympics in LA. LA is the place. 1984. I was there. Hope you're doing well. You got regular homework. Homework 84. Take care. Bye.